So here is another question on properties of electromagnetic waves. So it is given that the magnetic field in a plane electromagnetic wave is given by By is equal to 12 into 10 to the power minus 8 sine 1.2 into 10 to the power 7 Z minus 3.6 into 10 to the power 15 T, small t, that is time, Tesla. So from this we are clear that this By, it represents that the magnetic field variations, it is along the y-axis, and from this Z we are clear that the movement or the propagation of the electromagnetic wave is along z-axis. So this is the magnetic field. Then we have to calculate the energy density of the electromagnetic wave and the speed of the electromagnetic wave. So if you see this equation, it is representation of something like this, okay? By as a function of position and time is equal to B0 sine kz minus omega t. So far in the previous questions we always kind of dealt with something like this, B0 or E0 sine kx minus omega t or omega t minus kx, like that. So here this x, this y, this z, okay, which is attached with this wave number k, that represents the propagation direction. So here this z denotes that the propagation direction is along z-axis. Okay, the peak amplitude B0 of the magnetic field, that is equal to 12 into 10 to the power minus 8 Tesla, this much, and this wave number k, that is equal to 1.2 into 10 to the power 7. This is basically what? 2 pi by lambda. So from this we can calculate what? We can calculate the value of the wavelength lambda, which is equal to how much? 2 pi by 1.2 into 10 to the power 7. So this is coming around 5.23 into 10 to the power minus 7 meter. This is the wavelength. Then it is given this angular frequency omega, that is equal to this kz minus omega t. So this term attached with t, omega, that is the angular frequency in radian per second, that is equal to 3.6 into 10 to the power 15, this much radian per second. Now we know that omega is equal to 2 pi f, where f is frequency in hertz or second inverse. That implies f is equal to omega by 2 pi, which is equal to 3.6 into 10 to the power 15 by 2 pi hertz. It is coming around how much? If we calculate, it is coming around 5.73 into 10 to the power 14 hertz or second inverse. Okay, so now if we want to calculate, first we'll calculate the speed of the wave from this. So speed of electromagnetic wave, okay, the velocity or speed, that is equal to wavelength by time period, this much, we know that. So it is lambda by capital T. Now we know that frequency f in hertz, that is equal to reciprocal of time period. So this is in turn equal to lambda f. Okay, so lambda we have calculated here, this much, and f we have calculated here, this much. So simply it is the product of these two values. So that is equal to 5.23 into 10 to the power minus 7 into 5.73 into 10 to the power 14. So it is coming around 2.99. so approximately it is 3 into 10 to the power 8 meters per second. Okay, this much meters per second, which is the speed of light in free space, speed of the electromagnetic wave or light, whatever, like, because light is an electromagnetic wave in free space. So the speed of the wave we have calculated. Now we have to calculate the energy density. So the energy density in terms of the magnetic component, okay, the energy density in terms of the magnetic component, that is equal to UB, is given by 1 by 2 B0 square, that is the amplitude of the magnetic component, by mu 0, which is the absolute permeability. So that is equal to 1 by 2 B0 is equal to how much? 12 into 10 to the power minus 8 Tesla square by mu 0, which is equal to 4 pi into 10 to the power minus 7, absolute permeability. So it is coming, the value, it is coming around 5.73 into 10 to the power minus 9 joules per meter cube. This is the average energy density in terms of the magnetic component. Now you could have also done it in an alternative way, where you could have found E0 using the relationship, which is E0 by B0 is equal to C. So E0 is equal to C B0. Then you could have calculated the energy density in terms of the electric component, which is equal to UE 1 by 2 epsilon 0 E0 square, like this, where epsilon 0 is the absolute permittivity and E0 is the amplitude of the electric component of the electromagnetic wave. So this is also you could have done, you would have got the same result, but here directly B0 is given, so in order to save time we did that, obvious choice. Okay, so this is the